Thank you very much for the opportunity to speak this morning. Want to cover a bit of around hydrogen's implications, where we see hydrogen playing a key role in the energy transition, and I suppose try and touch on some of the key points that need to be addressed to really make hydrogen happen at scale. So very quickly, for those who don't know, Johnson Matthey is a FTSE 100 company based in the UK, just over 15,000 people globally, just over 200 years old. One key element is we're very technically focused, so our real underlying for all of the different markets we're involved in is sustainable technologies. And we really invest heavily in R&D and look for the key elements of chemistry, catalysis, and other people's processes where we can help and support. Hydrogen has many such areas, and we'll try and cover some of those as we go through this presentation. So first of all, why are people talking more and more about hydrogen? Well, I think one of the critical changes has been this desire or targets and ambition to achieve net zero. The change from an 80% emissions reduction to net zero has really highlighted areas of our energy system which are hard to abate. And these are the critical areas where hydrogen can really play a key role. And we'll try and describe some of those as we go through the presentation. You'll all have seen, and this is probably slightly out of date now, being December 2020, the way things are moving in this arena. It's only accelerating, but more and more countries are now backing net zero, defining their own targets and actually legislating. What this is really doing is highlighting the fact that the large amounts of GDP are associated with achieving those net zero targets. COVID has happened, is still happening globally, but what we're really seeing is that's not slowing down this trend. It may have distracted people, and I think that's an important part that we may pick up later on. The fact that what is critical for us to achieve net zero is for us to be starting now, to be deploying at scale, not waiting, not seeing that this is a problem that we can come back to, really needing to drive action today. Whilst we're talking about hydrogen, we have to put it in context of a global energy system. What we'll have seen, and you'll have seen recent headlines around the fact that we've had more renewables, particularly in the UK, contributing to our energy system than ever before, actually heading towards a tipping point where more renewables are being used than fossil fuels. But mainly this is for electricity, or nearly all of this is aimed at electricity generation. And that's absolutely right. What we're not here to do is say hydrogen's the only solution. Hydrogen is one of the solutions that will help us get to net zero. Actually, the electrification is going to be critical, and how hydrogen interfaces with that electrification or by renewables will be key. So we very much see that there are real markets, large markets for light duty transport, most rail applications on main lines, some heatings in homes and light industrial processes where electrification will be critical. We've got to remember we're moving from a global energy system that today has about 80% energy coming from molecules, whether that's fossil fuels as coal, oil and gas, versus 20% from electricity. So the growth in our electricity system is going to have to be massive. Where we see hydrogen, and we'll come into the different routes of getting to hydrogen, are in the energy intensive industrial uses. So these are primarily things, cement, steel manufacture, but also a lot of high temperature processes used in industry, which will really struggle in the near to medium term to shift to electrification. heavy duty transportation, marine, and some rail applications, particularly branch line type applications, we also see as really critical areas, these hard to abate sectors where hydrogen will play a key role. Also, we certainly see examples coming through globally of where larger and longer range light duty transport will also benefit greatly from a shift to hydrogen. Aviation's on there. I will have to wait and see whether we'll ever be flying a jumbo powered by hydrogen, but there are many other applications within aviation where hydrogen will certainly be a key enabler to decarbonising that sector. And equally, we're going to start seeing areas where we're going to get crossover between renewables, hydrogen, and then potentially onto things like sustainable aviation fuels. That's shown a little bit here in this, this flow diagram, where there is the potential that we can move from to a system where we're using renewables and water to generate hydrogen through electrolyzers. We can pull CO2 either from waste sources, from industry, or from, for example, the use of biomass to create power. We can then upgrade that to hydrocarbons by a variety of different routes. Many of these are technologies that Johnson Matthey is actively engaged in, either by providing components or full technology processes, where we can then get to fuels, chemicals, fertilizers, all to drive a more sustainable and greener future. Now, this is a technology-driven map at the moment. We know how to do these blocks. What we don't have in place is the market conditions to make many of these things happen. Particularly when we're looking at things like the ammonia and methanol market. These are global commodity traded chemicals. We will need a global market or a differentiated market to drive low carbon equivalents or low carbon options. And we will have to be looking at how we deal with that global trade. Other elements such as sustainable aviation fuels, which will be driven through things like upgrading via Fischer-Tropsch synthesis, where we take potentially CO2 and hydrogen through to jet fuel or kerosene. That can be more of a localized market within a country. But we are going to have to think about how we enable these new routes to compete with the current routes via fossil fuels. Back to hydrogen. You're probably all aware of the rainbow that comes with hydrogen, and I'm only showing 4 of the different colors that are often mentioned. A brown hydrogen coming from coal, very high emissions, but you can see is a very low cost per kilogram of hydrogen, and that's the competition we're in. Most hydrogen today is produced by steam reforming of natural gas or grey hydrogen. This is a segment where Johnson Matthey supplies catalysts globally. Again, a high emissions per ton of hydrogen, but again, a very competitively priced product. And this is what we're having to compete with. When we move to blue hydrogen, where we again use natural gas, but now use carbon capture and storage, we can dramatically cut those emissions. Johnson Matthey developed a technology called LCH, where we use key part of that is that we use differentiated technology to drive down the overall emissions by making it as easy as possible to capture the CO2 from the process as cost effectively as possible. And we can achieve over 95% CO2 capture, in some cases up to 98%. This again is a relatively low cost process, but is more expensive than today's grey hydrogen. So we do need to work on ways to make that transition happen, whether that comes from a carrot and stick model, where there's subsidies for blue hydrogen and the stick being more like a carbon price, which then reduces the amount of grey hydrogen that's produced. We will need these market mechanisms to enable this. And I think that's one of the take homes that I'd like people to go away with, is that it's not about the technology, it's about the market and how we stimulate this change in behavior. Finally, green hydrogen. Really what we're talking about here is water electrolysis, either from alkaline electrolyzers or polymer electrolyte membrane electrolyzers. This has the potential to be a zero emission technology if we are using 100% renewable electricity to generate hydrogen. Currently, the prices are high, but that's as much as anything due to electricity prices still being relatively high as a key feedstock, and also the relatively small size of the supply chain, which will have to grow to meet some of the aspirations. What could hydrogen do in the future? These are numbers that we've pulled from some work from the Hydrogen Council and IEA. Maybe focus less on the split between blue and green hydrogen. We can argue about that probably till the cows come home. The key thing here is we're seeing a dramatic growth in hydrogen between today and 2050. This is shown in terawatt hours. Grey hydrogen today, still a substantial amount of hydrogen is made. The emissions from that are equivalent to the total emissions from the UK and Indonesia combined. So not insubstantial. And we will have to see that phase out over the decades. This will happen as current existing assets go out of action, come to the end of life, and we'll start seeing the growth of blue and green hydrogen. And really you can see that we're looking minimum a 10-fold increase in the volumes of hydrogen required. So grey hydrogen is going to decline due to future carbon prices. We think blue hydrogen will be picked up and adopted in areas that have good geology to allow carbon storage to happen cost effectively, but also areas which have a strong infrastructure for natural gas and distribution of natural gas. Those are areas which will really suit blue hydrogen. UK being one example, but equally the US and Canada, which have a large access to low-cost shale gas. We don't see this being a question of blue or green. It's blue and green. You can see the amount of hydrogen we need there is, phenomenal in terms of change over 30 years. So it's not about one or the other. And actually, there are a lot of synergies between blue and green hydrogen. Certainly, we're seeing a lot of interest in green hydrogen in areas which have very low cost renewables. You can see this being places like Chile, which have a lot of solar and particularly wind. Areas such as the Middle East, where there is equally a lot of low cost solar. But the same here in the UK. Up in Scotland, we have the ability to tap a really large offshore wind resource, and green hydrogen could well be a way of driving that. Because remember, we've got to move from an energy system with 80% molecules and 20% electrons. We're going to have more and more renewable electricity, more electrons in the game. But to have a stable energy system, we need something that's balanced, that we can store. And this is one of the key elements that hydrogen can bring to a balanced energy system. Costs, and we mentioned briefly costs before. What we see is that essentially blue hydrogen will be one of the more cost-effective routes for a number of years, particularly in locations like the UK. But we do anticipate a large cost down in green hydrogen, and in some areas it will become more cost-effective to produce green hydrogen over time than blue hydrogen, with grey hydrogen becoming ever more expensive as carbon prices rise. So what's happening? Well, that's, you've already mentioned, Philippa mentioned in the introduction, the amount of news, discussion, talk around hydrogen is growing, ever growing. What this is showing is some of the commitments made by governments in terms of targets they're setting over different timeframes, some in different sectors, whether it's stimulating supply or demand. But really the underlying message is this is a global thing. We're seeing more and more countries engaging in looking at hydrogen and really looking at hydrogen at scale. And the key there is that will then increase the supply chain and drive down costs. However, it's no point just looking at what governments are targeting and the ambitions they have. We also need to really consider projects. What this is showing is that there are a large number of projects that have been announced globally. And also there's a difference in where these different countries, different regions are targeting that within the supply chain. So it's not all just about production. It's how you produce hydrogen and then how you transport, store and distribute it. And then the multiple end uses that you can really take up that hydrogen. Different countries have different strategies and are focused on different areas of their energy, of their economy, different sectors. However, it's relatively easy to announce projects, and here you'll see that there is many more projects that have been announced. But I think what's key is that we're also seeing these announcements transitioning from that very early stage, now moving into planning and post-investment decision. Critically there, final investment decisions where people are now starting to really construct, commission and operate these projects. And that's accelerated rapidly over the last few years. Back to the UK, I do think the UK has a real opportunity to be a world leader. We are very positive about things like the announcements made through government in the 10-point plan at the back end of last year, where hydrogen was very prominent. We also see the requirement for growth in renewables to drive green hydrogen and the importance of carbon capture and storage for blue hydrogen. All of these are real telltale signals from government that they are absolutely going to push this forward. We are waiting for the hydrogen strategy that should be due out in the next couple of months. And these have really quite ambitious targets. Maybe some of the other speakers will challenge whether they are ambitious enough. But to be looking at 5 gigawatts of hydrogen by 2030 as a minimum is a really good starting point. I think key to what the UK has done and UK government has done is they pushed funding at an early stage into some key projects around the UK that can really be world leading. So 2 projects that I'm mentioning here, HyNet up in the northwest of England. This is everyone likes different units, but 80,000 tons per annum of hydrogen or 350 megawatts equivalent. This is a large blue hydrogen project, which is you're going to use Johnson Matthey technology at its core. Particularly relevant here is that that's going to be used in industry in the first phase. But what we really see is that the clusters will start building. And once we have these clusters of large volumes of hydrogen being produced, we'll see spillover into other sectors. So while industry might be the first starting point, as subsequent phases come online, we'd equally anticipate that being blended into the gas grid and used in transportation. Another project up in the northeast of England this time is the Gigastack project. This is using electrolyzers, specifically again electrolyzers coming from a UK company called ITM. So really seeing that we have 2 world-leading projects that are really pushing UK technology and UK content to the fore. This project up at 100 megawatts would be the largest electrolyzer installation in the world, using offshore wind from the Hornsea 2 wind farm out in, and this is one of the many projects that focused on decarbonising the industrial sector around the Humber. A lot of the hydrogen will go into the refinery, some of it likely to be replacing existing uses of grey hydrogen. So I think summary of that is that the UK does have an amazing opportunity to be a world leader, really for us to drive a legacy into the UK, particularly into the supply chain. And that's all elements, it's services, it's engineering, it's manufacturing. We need to be one of the first and not to be a follower. If we're a follower, we'll end up importing key elements of the supply chain. So I think this is one of those timings where we've done a lot of good work. We've made some really impressive start, but we've got to follow that through and we've got to deploy these projects at scale. The really critical next step, hydrogen strategy is part of it, but it's the business models that are going to allow these projects to go ahead, which are really going to define the position we can take in the UK. Very quickly then, just heading towards wrapping up. There is a lot of interest in fuel cell electric vehicles, and these do run across multiple sectors. One of the elements that everyone always talks about is the infrastructure, so the hydrogen fueling stations. We are seeing more and more plans and strategies coming along from multiple governments that are looking to install these. We need a similar element within the UK. This will then drive both the uptake of light vehicles and heavy vehicles. And it will be, once we have the infrastructure in place, we will be able to see the uptake of fuel cell vehicles in multiple sectors, heavy duty vehicles being one where we see real need for that deployment. Oh, and then finally, I think you'll all seen kind of pictures like this. One of the key elements is the power that hydrogen brings you, is that when you start bringing it into these clusters, it has multiple different uses. We can export it by ship, by pipeline. We can be using it for shipping. We can be using it to produce synthetic fuels for aviation, clean mobility, replacing existing grey hydrogen in commodity products such as ammonia and methanol, reducing emissions from refineries, and also producing products such as green steel, low carbon glass, and other industrial processes. So we do see that these clusters will be critical to the beginnings for hydrogen, but these will then spill out, particularly in regions and areas which have a good existing gas grid, as we do here in the UK. So with that, Philippa, I will close and happy to take any questions.
Yeah, great. Thanks, Sam. I've got a quick question myself to start off with. You talked about the focus needing to move to deployment and that needed to be prioritised. Do you think that the projects like HyNet that you discussed are good enough to accelerate this market uptake in terms of the deployment factor, or does more need to be done? And should we be prioritising particular areas?
There's a few questions in there.
Sorry.
So HyNet's one example. There are great projects up at Acorn in Scotland, at St Fergus. The projects announced by Equinor in the Humber and now BP in Teesside. We'll need all of these. Along with multiple large-scale electrolyzer projects. We need to start somewhere though. So getting some of them over the line as quickly as possible is important, with the view to then being ready to deploy at scale through the 2030s. So it's certainly not just about doing a couple of projects and then sitting on our laurels. It's really about developing a pipeline. Key to that will be getting the business models over the line. Likely that there'll be individual negotiations for the first projects, but then we could well see ourselves in a position similar to offshore wind, where we've got kind of CFD type auctions happening at set periods during the 2030s.
Great. Right, a couple of quite a few questions actually coming in towards last day. So first of all, we're going to go to Mark Sanford, who I believe is going to ask his question live.
Yeah, is that working?
Yeah, I can hear you, Mark.
Yeah, so I'm particularly interested in the relationship between the green and blue hydrogen. And I was wondering if you had a rough idea or prediction for when essentially green hydrogen could overtake the production of blue hydrogen in the UK, and if you think there's any tipping points that green hydrogen could overtake blue, for example.
It's my fault in terms of introducing the rainbows of hydrogen. I'd really prefer if we talked about low carbon hydrogen and actually got into some of the sort of life cycle analysis for these different routes. But on your question, there will be examples where the cost of green hydrogen will become lower than blue hydrogen in areas which are further away from the clusters, where you have to start paying for transport and potentially storage, and actually producing locally will be cheaper. Driving down the cost of renewables in certain areas will also make that happen. As well as I think there's some technical advances required in green hydrogen, but the main thing will be driving up the supply chain volumes, which will drive cost out of the capital. I can't give you an answer of when the tipping point would be. I think some of that will come down to what government do in terms of whether electrolyzers can access wholesale electricity prices, whether grid connection fees are waived, VAT, all sorts of complicated elements to their business model. Key for me is I think we need both, and I think we need large volumes of both. So I'd be less about one or the other, but more about driving and making sure both have support particularly as they fit well with different parts of our energy system. Now, high temperature, large baseload requirements through industry probably fit much better with a blue hydrogen approach, whereas a more distributed network of hydrogen refueling stations, as well as areas that are far away from carbon capture and storage, we should be driving the use of green hydrogen.
Do you have sort of any sort of ideas around those sort of prices that will be needed?
Hydrogen pricing is quite difficult actually, because today, there isn't really a hydrogen market. Most grey hydrogen's produced and captively used, so over the fence with direct contracts. What I think we'll see in the near term, and this is work that BEIS are doing at the moment around business models, is that the production side will be subsidized, and therefore the consumer will pay, large industry consumers will pay about the same price as natural gas. Now, over time, that subsidy will drop off as the cost of production comes down and the cost of gas rises via a carbon price. So I don't think I'm talking out of turn, but I think that's the favored model from government for at least large scale production. For smaller scale production, primarily from green hydrogen, it's likely a different business model will be invoked. And there probably you're also targeting higher value market opportunities such as transportation fuel, which on the whole can carry a higher price. But there are mechanisms such as the renewable transport fuel obligation, which, if done correctly, would provide a sufficient subsidy to make the business models work for green hydrogen. So it's not a simple answer. There are different models for different industries, but large scale industry, you could even think that that could extend to domestic heating. You would look at mapping to a reference price of natural gas.